Hello. In this lesson we're going to talk about derivatives of logarithmic functions. If we have a function y equals to ln x, the derivative dx of ln x is going to be 1 over x, or in Lagrange notation, derivative of ln x is going to be 1 over x. How can we prove something like that? If I have this function y equals to ln x, then I can also rewrite it such as x equals e at power y. What can we do with this is derivate both expressions on the left and on the right separately and see what results can we obtain. So I'm going to say derivative of x equals to derivative of e at power y. Now derivative of x in regards to x is 1, and the other one I'm going to apply the formula e at power f of x. So the result is going to be e at power y times derivative of y. Reorganizing this expression, we can say that y prime, or derivative of y, is 1 over e at power y. And e at power y is nothing else than x. So that's why the derivative of a logarithmic function, natural logarithm of x, is 1 over x. Now, let's clear this out and let's see what is the derivative for a function y equals ln of f of x. Then we can write the derivative dx of ln of f of x is the derivative ddx of f of x over f of x. Or we can write the same thing with Lagrange notation. It's probably more clear this way. How do we prove something like that? Well, once again, we're going to use the properties of the logarithm just like before. So if y equals to ln of f of x, then that means that f of x is e at power y. And we're going to derivate both expressions once again. So we're going to have f prime of x equals to the derivative of e at power y. If we continue, we're going to have derivative of f of x equals to e at power y times derivative of y, applying the formula for e at power f of x. And reorganizing this expression, derivative of y equals to derivative of f of x over e at power y, which we already said it's nothing else than f of x. So our formula is proven once again. Now let's make room for another formula. If y equals log in base b of x, so for any type of logarithm with any base, not only for the natural logarithm, then the derivative ddx of log in base b of x is going to be equal to 1 over x times ln b. Or using the Lagrange notation, we can write the same thing. To prove this rule, let's calculate rewriting this logarithm in base e. Because we already have the formulas for the natural logarithm, we can use them now. The derivative of this log in base b of x is equal to, I'm going to change this logarithm into a natural logarithm, so it's going to be ln of x over ln of b, the old base, is going to be the derivative of all this expression. This ln b in the denominator, it's actually a constant multiple, which we can factor out as 1 over ln b, and we are left with just the derivative of ln x, for which we already have the formula, and it's proven, everything is fine, we can just use it. So it's going to be 1 over x times ln b. Let's write one more formula, the more general form if you wish. If your function y equals to log in base b of a function f of x, then the derivative is going to be ddx of log in base b of f of x is ddx of f of x over f of x times ln b. Or using the Lagrange notation, to be a little more compact, is f prime of x over f of x times ln b. And we can prove this once again using the properties of the logarithm. So basically the derivative of this function log in base b of f of x is going to be, just like before, change the logarithm into a natural logarithm. This is going to become ln of f of x over ln of b. We calculate now the derivative of this quotient. Ln b is a constant, so I'm going to factor that out. So it's going to be 1 over ln b, and we are left with the derivative of ln of f of x, for which we have the formula. Is going to be derivative of f of x over f of x. With this, we have proven the last rule for derivatives of logarithmic functions. Derivatives of logarithmic functions are not covered in the Calculus and Vectors course that's being taught in Canadian schools, in Ontario at least. Therefore, you may want to skip this lesson. For anyone else, I hope you enjoyed it. Thanks for watching.